Welcome back for the final video of this chapter. We're going to talk about density and problem solving in this video. Starting off here talking about density. Density is one of a few different relationships we're going to come across in this class where we can use the property itself essentially as a conversion factor. In this case, we can use it to convert between mass and volume, because that's essentially what density is. It's the relationship between the mass and the volume of a material. Density is a physical property that is unique to every substance. And what I mean by a physical property is, well, actually, we'll talk about this a little bit later on, but essentially, a physical property is something that you don't actually have to change the material in order to measure it. So we can measure the density of something without actually chemically reacting with it. And it can be dramatically different from one material to another. So iron, on one hand, is very dense, while styrofoam has a very low density. So what the density is it's just the mass of something divided by its volume. As simple as that. If you want to find the density of a material, measure its mass, and then divide that by its volume. And that is the density. It's how much stuff is packed into how much space. That is the density. So water, as an example, has a density of 1 gram per mil. For every milliliter of space that water takes up, you will have 1 gram of mass. Now iron is 7.87 times more dense. It has a density of 7.87 grams per mil. So if we think about the differences here, if we had equal volumes of these two things, which one would weigh more? Hopefully, the first thing that came into your mind was the iron would weigh more. Yes, it would. This would be like saying if you had a gallon of water, which is not light by any means, or a gallon of iron. Like, that's going to be really heavy. It's going to be 7.87 times as heavy as the water, actually. So if you have equal volumes, the iron weighs more. If you have equal masses, which one would have greater volume? That would be the water. The water would have a greater volume, because if you had, let's say you had 10 pounds, just to use a unit that you're familiar with. If we have 10 pounds of iron and 10 pounds of water, the 10 pounds of iron might fit into your hand easily, like a little iron ball would be 10 pounds. Water, on the other hand, it would probably take a couple gallons. I forget exactly what the mass of a gallon is, but it would take up a lot more space because it's less dense. All right, let's do a couple quick practice problems here. How much does 6.44 mils of iron weigh? So there's a few different ways we can solve questions like this. The most common way that I see people solving these, and I think it makes sense to do it this way, is to just treat this equation, well, like an equation essentially, just to treat it as the conversion factor itself. So just to plug in everything that you know into this equation, and then solve for the one thing that you don't know. Oftentimes I will instead try to use the equation as a conversion factor and flip it around whichever way I want. But I think just plugging the things directly into the equation actually makes it a little bit simpler. So for this particular example here, actually, why don't you try it first before I explain how to do it. So go ahead and pause the video and try to figure out how much 6.44 mils of iron weighs. All right, I hope you gave that a shot. So if the density is equal to the mass divided by the volume, and in this case we're trying to find the mass, what we're going to do is we're just going to plug in what we know. So we know the density of iron is 7.87 grams per mil. We're trying to find the mass. We don't know that, but we're told that we have a volume of 6.44 mils. So we just plugged in what we knew into the equation here. If we're trying to solve for the mass, we need to get it by itself. The easiest way to do that is just to multiply both sides by 6.44. So if we do that, multiply both sides by 6.44 mils, we end up with, let's see, 50.7 grams. And it's grams because the milliliters here are going to cancel out with the milliliters there, leaving us just with grams. So 50.7 grams. What about 50 kilograms? What volume does that occupy? So it's going to be the same process for this one, only it's going to be a little bit different because now we have kilograms instead of grams, and the density we have is in grams. So we could go one of two ways. We could convert the density into kilograms. I think that would be the more confusing of the two ways. I think it's easier to convert our kilograms into grams. So 50 kilograms, kilo is 10 to the third. So 50 kilograms is actually the same as saying we have 50 times 10 to the third grams. And so that's what we're going to use for our mass. If you want to see that in the using unit conversions, instead of just converting the kilo directly, it would be something like this. So there's the 50 kilograms. We know that for every 1 kilogram, there's 1,000 grams. So those kilograms cancel out, and that would leave you with 5.00 times 10 to the 4, I guess, grams. Which, by the way, is just the same as this. It's the same number. Okay, so with that in mind, we know the density is the mass divided by the volume. And we know the density is 7.87 grams per mil. We just figured out that the mass is 5 times 10 to the 4 grams. We are trying to find the volume. To get the volume by itself, we're not going to divide both sides by 5 times 10 to the negative 4. That would get the volume by itself, but it wouldn't be the volume. It would be 1 over the volume, since the volume is in the denominator here. So what we actually are going to do is we're going to multiply both sides by the volume divided by the density. And just pretend like I drew that over here as well. So what that's going to end up doing is it's going to cancel out the volume over here, and we're going to end up with the mass divided by the density. And this 7.87 is going to cancel out. And so if we do that math, so again, I guess I will go ahead and write it here just so you can see what happens. So sorry for scrunching everything in there, but that 7.87 cancels out with this 7.87. So we're left with just the volume. So the volume is equal to 5 times 10 to the 4 divided by 7.87, which is 6.35 times 10 to the third milliliters. Or if you prefer, 6.35 liters. All right. Just real quick, if you don't like the algebra that we did here, if you saw that algebra and you thought, "Ooh, what the heck just happened?" It is usually actually easier to do the algebra at the beginning rather than in the middle. So what we could have done instead was, instead of starting with the equation like this, density is equal to the mass divided by the volume, we could have done the algebra at the beginning and done the conversions to find that the volume is equal to the mass divided by the density. And that, it's technically the same number of steps, it's just kind of, it's easier to do it without the numbers in there. So if that makes sense to you, please feel free to do it that way from this point forward, doing the algebra at the beginning and then just plugging in the numbers from there. Alright, last thing here is just kind of a brief explanation of the method that I use when I'm looking at a problem for the first time. The question that I'm always asking myself is, how do I get from the information that I have to the information that I want? Because you're always given at least some information in the problem, and you know some information from lecture and lab and things like that. And so I'm always trying to ask myself, number one, what am I looking for in the first place? Because often there's confusion when it comes to that. So what am I actually looking for? What do I know that relates to that? And then what am I given in the problem? So I always start consolidating all my knowledge about the thing that I'm looking at, and then taking that and seeing if I can work out a pathway between what I'm given in the problem and where I'm trying to go. So this here, I'm not going to work through all these steps with you here, but I would encourage you to look this over and consider using some kind of a system like this if you have, if you don't have a system that you use already. And then one final thing here, when you're solving the problem and doing the math using the calculator, I would double check when you do that, just because calculator errors are fairly common, unfortunately. So, and it doesn't really hurt to punch it into the calculator real quick a second time to make sure you get the same answer again. So that'll be it for this chapter. See you all in Chapter 3.